Welcome class. Today we're going to be learning about the distance and midpoint formula. So let's first derive the distance formula. Okay, I have my graphing board here. Now I know that you can't see it that well, but I do have it up so that my lines are nice and clean and straight. So notice I have 3 points here. I have my first point P, which is at x1, y1, Q at x2, y2, and R is at x2, y1. Notice here that P and R are located on the same. As X changes as you move across from the left to the right, the Y value stays the same, which is your vertical axis. So that is why they're the same, Y1, Y1. From R to Q here, oh, I said I was going to make straight lines and I did not. Okay. Notice here that your X2 and X2 are the same because you're at the same X value vertically, and the Y value is what changes. So I have Y2 and Y1. Okay, so we know how to calculate the distance if I have a horizontal and a vertical change, right? Here, notice that y1, y1 is the same, so to find the distance, all you would have to do is subtract x2 minus x1. To find the distance vertically, you would subtract y2 minus y1. But the question we're going to answer today is, well, how would I find the distance from P to Q? Okay, and to find this distance, we're going to use the distance formula. Notice here that I created a right triangle. So remember from our lesson yesterday that if I have a right triangle, okay, and there's a distance that I want to find, I'm going to use the Pythagorean theorem. Okay. This distance here is going to be my hypotenuse. Okay, so I'm going to call this here, this is side PQ. Okay, side PQ. And I do know the length of this bottom piece here. We mentioned earlier that it is going to be x2 minus x1. And this right side here is going to be the difference of your y's, y2 minus y1. So let's come over here and plug that into our Pythagorean theorem from yesterday. Remember, the Pythagorean theorem is a squared plus b squared is equal to c squared, where a and b are the legs of the right triangle. So the legs extend off of the right angle, so my first leg is x2 minus x1. So I'll plug that in here, x2 minus x1, square it, plus my second leg, which is y2 minus y1, square it, y2 minus y1. And that's going to be equal to my hypotenuse here, which is the distance that I'm looking for. And actually, since we're deriving the formula, I'll just go ahead and call this the distance, which is d. Okay? So that's going to be equal to my distance squared. Okay? Now, let's solve for distance, right? I don't care about distance squared, I just want the distance alone. So how do I undo when I square a number? The opposite of squaring a number is to take the square root. So I will take the square root of both sides. Therefore, the distance, which I'll switch these here, so therefore the distance formula is going to be the square root of here, x2 minus x1 squared plus y2 minus y1 squared. Okay? And next we'll do an example to help you navigate how do we evaluate this type of an equation. Okay, in this example we're going to find the perimeter of the quadrilateral that I have drawn here. Okay? Notice I have 4 points. Okay, the 4 points connect, they create a quadrilateral that we want to find the perimeter of. Remember, the perimeter is the sum of all the sides. So we're going to have to find the distance between each point for each side. So I have 4 sides, side 1, side 2, side 3, and side 4, right? So we are going to have to use the distance formula 4 times to find these values, to find the lengths of the sides of this quadrilateral, okay? So to do that, we're going to have to do it one step at a time. So let's first talk about this side here, from A to B. So for side AB, okay, we're going to use our distance formula, okay, where we can call, let's first write down our points. A is at -2, 2 here, and B is going to be at 3, 4. Okay, I'm going to go ahead and call them x1, y1, and x2, y2. It doesn't matter which one that you call x1, y1 or x2, y2, as long as that you are being consistent. So if you're going from A to B, then you need to shoot that direction both times. -2, -3, 2, -4. Or if you're going from B to A, you have to be consistent again. 3 minus negative 2, and 4 minus 2. So I'm just going to call A, let A be x1, y1, and B be x2, y2. So let's plug these values into our distance formula. So the distance is going to be the square root of x2 squared. So x2 here is 3. Plug in 3. So x2, 3, x2 minus x1 squared. So x2 is 3 minus, here, minus negative 2 squared. I hope that you're noticing here that I have two negatives, which will create a positive. So you'll have to be careful. 3 minus negative 2 is the same as 3 plus 2 when we go to evaluate this. Okay, then I'm going to add it to y2, which is 4, minus y1, which is 2, and square it. Okay, so now I have the distance is equal to, let's simplify our parentheses, 3 minus negative 2, we just said is going to be 5 squared, plus 4 minus 2, which is 2 squared. Okay, we evaluated the parentheses. Let's move on to evaluate the exponents. The distance is now equal to the square root of 25 plus 4. Add your numbers together, so the distance is equal to the square root of 29. Okay. Now, for accuracy, I want to go ahead and leave this as the square root of 29. At the very end, we're going to find the perimeter and add all of these values together. So to conserve accuracy, I just want you to keep it as the square root of 29 until the very last step when we add them all together and plug them into your calculator. So I'm going to come over to my quadrilateral and label this as the square root of 29. Okay. We can go ahead and move on and do the same thing for the line segment between B and C. So point B is at 3, 4, and point C is at 3, negative 3. Okay. At any point, you should go ahead and pause this video, see if you can come up with the answer on your own, and then press play to see if you're correct. So the distance here, let's call B now x1, y1, and C x2, y2. So the distance is going to be equal to the square root of x2, which is 3, minus x1, which is also 3, squared, plus y2, which is negative 3, minus y1, which is 4. Now we can simplify by evaluating the parentheses. 3 minus 3 is 0. We know that 0 squared is just going to give us a 0, plus negative 3 minus 4, which is negative 7 squared. Be careful that negative is included when you square this number. So negative 7 times negative 7 is going to leave you with a positive 49, plus 0 is just going to be the square root of 49. And we know that the square root of 49 here is 7. Okay. Remember from last chapter, we said, well, when you take the square root, Miss Ayers, you have a positive and a negative. And that is true. However, we're talking about distance. So just like when we talk about triangles, I'm only interested in that positive value because distance cannot be negative. So I know now that this side here is 7 units in length. This side here is square root of 29, and we'll move on to find the last two sides as well. Okay, I noticed I forgot down here that this point is actually D, negative 3, negative 2. So now let's evaluate this side here from C to D. I'm going to call C x1, y1, and D x2, y2. Go ahead and plug these values again into my big old square root formula. x2 is negative 3, minus x1, which is 3 squared, plus y2, negative 2, minus y1, which is negative 3, and square that as well. Okay. Evaluate your parentheses. Negative 3 minus 3 is negative 6 squared, plus negative 2 minus negative 3. Remember, we're going to add here. Two negatives make a positive. If it helps you out, make a big old plus sign. Negative 2 plus 3 is equal to 1 squared. Okay. Evaluate those exponents. Negative 6 squared is 36, plus 1. And now you're going to have the square root of 37. Again, this is not a perfect square, so I just want to leave this in my square root format. Bring it over here, plug it into my chart, and I have the value of the square root of 37 is the distance from C to D. Okay, we have one left side to go. Let's evaluate the last side from A to D, where A is at -2, 2, and D is at -3, -2. So I'll label them again, x1, y1, x2, y2. I do recommend labeling. It helps you stay organized when you're plugging in these values into the distance formula. Okay? x2 is at -3 minus x1 at -2 squared plus -2 minus 2 squared. So the distance is going to be equal to -3 plus 2, two negatives make it positive, -1 squared plus -2 minus 2, -4 squared. That distance is now, evaluate your exponents, -1 squared is 1 plus 16, and we end up with the square root of 17. So now I know the values of all the sides of my quadrilateral, okay? So to find my total perimeter, what I want to do now is add up all of these sides. So the perimeter is going to be equal to, and this is what you'll type into your calculator. Remember, in order to conserve accuracy, we do not want to calculate these square roots until the very end. So all in one swoop, we're going to type into the calculator the square root of 29 plus 7 plus the square root of 37. And this is where it's super important. Remember I told you to use the parentheses. So when you type this into your calculator, the square root of 29, a set of parentheses shows up. Okay, you must end those parentheses to tell the calculator that the only thing that you want the square root of is 29. Otherwise, it's going to start taking the square root of all of this together. Okay, so notice that there's more square roots. So it will take the square root of a square root of a square root, and we don't want that. So we have the square root of 29 plus 7 plus the square root of 37 plus the square root of 17. Okay, then you can hit enter button into your calculator and find the sum, which will be approximately, you will get some decimals here. Just listen to the directions. It tells you to round to the 10th or round to the hundredths. I'm going to round to the 10th here. So this will be 22.6 units. Okay, I'm not sure what these are. If they're feet, inches, didn't tell me, so I'm just going to use the word units. In the second part of this lesson, we'll be talking about the midpoint formula. So the midpoint divides a line segment into two equal parts. So notice here I have the line segment from A to B. I want to find the midpoint of this line segment. So let's call A to be at x1, y1. Oh, I'm sorry. And B to be at x2, y2. So in order to find the midpoint here, well, how would you find halfway through something, right? One way to do it is to find the average. So if I want to find the midpoint here, I'll call it M. Let's first talk about the x-coordinate, okay? I have the x-coordinate and the y-coordinate. So to find the x-coordinate, I want to know halfway between x1 and y1. So I can add them, x1 plus x2, and then divide it by 2. Take the average. Okay, remember the average is the sum of all your numbers. So my two numbers are x1 plus x2 divided by the number of numbers, which I have two numbers. So I add x1 plus x2, divide by 2. The same goes for your y-coordinate. You can add those values, y1 plus y2, to take the midpoint, or to find the midpoint, then divide it by 2 to get the average y value. And so this here is the midpoint formula. Let's look at this first example for the midpoint. Let's find the midpoint between 2 points. I've been given 2 points, C and D. Okay. Just like when evaluating the distance formula, my advice to you is to label each part. So I'm going to call C x1, y1, and call D x2, y2. To find the midpoint, or the middle of the 2 points, I'm going to plug this into my midpoint formula that I have in the top right. So the midpoint between these two is going to be the x-coordinates. You're going to add the x-coordinates, -1 plus 3. -1 plus 3 in the numerator, then divide by 2. Your y-coordinate, add both the y1 and y2, 5 and 0. 5 plus 0, then divide by 2. So we can simplify this now. So the midpoint here, -1 plus 3 is 2. 2 divided by 2 is 1. And 5 plus 0 is 5. Divided by 2 would be 5 halves. So you can write that as 5 halves or 2.5, whichever your preference is. So M is at 1 5/2, and that's going to be the midpoint between these 2 points C and D. Let's look at another example. I'm going to ask you here to find the center of the circle. Notice here I've been given the diameter. The diameter goes across the circle and it passes through the center. I want to find the center of this circle. To find the center of the circle, it is the midpoint between -1 5 and 4 3. Again, label your points. I'll call this one x1, y1, this one x2, y2. And now I can plug into my handy dandy midpoint formula. So the midpoint here is going to be equal to the sum of my x coordinates, -1 plus 4. Divide that by 2. And my y coordinates, 5 plus -3. Also divided by 2. Now we can simplify. -1 plus 4 is 3. So I have 3/2. And 5 plus -3 is 2. Divided by 2 is 1. So the midpoint of the circle, or the center of the circle, is at 3/2, 1. Again, you can leave it as a fraction or write it as a decimal. In this section, it is your preference. So I have the homework posted. Get that completed and uploaded today. I do want you to go back to all of the assignments and upload your notes to them. So when you go to the assignments tab in the top right corner, should be a plus, add, or create tab. From there, you can upload your notes to those sections. This way, it'll save you from, at the end of the chapter, having to upload a whole bunch of notes pages. So this way, each day, you could just upload the 1 or 2 or 3, depending on how big you write, pages of notes that you have, and that's going to be counted as your notes grade. Okay. Again, if you have any questions, please do not hesitate to text, call, or email me directly. And hope you're staying safe and having fun at home. Bye.